If I am asked to name one thing which fascinates nearly every human mind, big or small, rich or poor, I'll unhesitatingly name it as fire. Fire, a symbol of life, of knowledge, is also a symbol of death and destruction. In this series of demonstration and experiments, I am going to deal with the science of fire. Though mankind for millennia has been creating, controlling and continuing with fire, yet the science took several centuries or even a millennia to understand it. The first person in recorded history to make experiments on fire in the state of Byzantium, and in his writing in 200 BC, he mentioned about the four elements which went to constitute the universe, and they were earth, air, water and fire. And to show this, he performed one of the simplest experiment which has been thereafter repeated thousands of times with different results. The Greek engineer and scientist took a metal vessel, a flat metal vessel, and put in the center mounted a candle made out of animal fat. He poured some water around the candle and lighted the candle thereafter. As the candle burnt, he took another vessel and gently lowered over the candle. Let the candle pick up the fire. Now I gently lower the candle, the vessel over the candle without disturbing. The candle burnt inside for some time, and there was slowly some water rising. After nearly 15 to 17 seconds, the candle went out. As he waited, he saw there was a dramatic rise in water level inside the vessel. Wilmy explained it, saying that the fire element of nature, which was present in the air, went out of the vessel in form of light, thereby creating a partial vacuum, and that vacuum was filled by the water which was lying in the plate, which rose above to fill that vacuum. It was an acceptable solution then. The same experiment was performed by the famous Greek engineer Heron, famous for his Heron fountain. He also came to the same conclusion. And this experiment was repeated for several times in different centuries with the same result. It was only in the 16th century when Galileo again performed the experiment. And to his utter surprise, he found that though the water was rising in all cases, water levels were different for the same candle in slightly different surrounding and condition. What could be the reason? He expected that in a given vessel, whatever time you do with a candle, the same level of water should rise, because that is the amount of fire present in the air which will go out. I shall now perform another experiment done by Galileo, where he concentrated not on the quality of the rise but on the quantity of rise, and made the experiment more delicate and closer in observation. Galileo used a floating candle. After lighting the candle, he took a vessel whose volume was known, and he gently lowered the vessel over the candle. To his utter surprise, he found, however gently he lowered, there was a lot of bubbling going on when the vessel was kept over the candle. And suddenly the water started rising after bubbling. It rose for a while, then stopped. The candle was still burning, but the rise of the water stopped. Galileo was astonished. If the fire was going out in form of light, why should it stop rising? And then suddenly the candle went out. As the candle went out, the rising of the water became more dramatic. This was a very good observation by Galileo, and he came to the conclusion that this is not because of fire escaping, but is more what is called a thermoscope effect. There is hot air above the candle, and as we are trying to enclose it with the vessel, the hot air gets trapped inside, and that's why there is bubbling while we are closing it. But as the candle goes off, it cools down, and the cooling causes the rise of the water inside the vessel. Keeping this understanding in mind, he was the person who devised what is now known as thermoscope. It is a small glass vessel with a long tube, and that thermoscope was the beginning of what later would become the thermometer. Finally, when the vessel has cooled down, we see that the water has risen about 100 cc. The total volume of the vessel is about 1200 cc. So the volume vacuum created was around 1 upon 100 upon 12, 1/12 of the entire volume. These calculations became important in the later chemical experiments. Here I have, which led to a model of the thermoscope made out of a fused bulb. It has got a glass bowl shaped vessel below and a glass tube above. If I heat this tube for a while over this candle, and after heating I insert it in this liquid and leave it, we find that as the glass cools down, water starts rising, the colored glass liquid starts rising in this tube. And this was explained much of the phenomena of the rise. There is no candle inside the bulb, yet you see there is a dramatic rise of liquid inside this tube. And this was the beginning, what called earlier the first thermoscope, which led, as I told you earlier, the making of the thermometer.